Hey, this is Byron from Mr. Cherry's Blue 3 of Calc BC, and I'm covering the topic of converging series and the partial sum using that. So the question we're looking at today is how many terms do you need in order to get an error of 0.001? So first we can start by looking at the series, which is given right here. So it's a series from n equals 1 to infinity of the alternating series, so it's alternating every one negative, positive, and then over n. And so first we can look at the term, this first term we know it's negative, and then written out, so this is basically just a series written out right here. It's alternating negative, positive, and then so on. So first we need to look at 0.001 because we need to get, that's our goal for the error. So right here we see that 0.001 is 1 over 1,000, which you should know. And so basically with this series, it's basically just like a negative, positive 1 over the number. So from this we can look at like first one's negative 1 over 1, next one's positive 1 over 2, and then negative 1 over 6, and then so on. And so our goal is to get to a number that's greater than 1,000 on the bottom. So in order to do this, when we look at the series, we see that it's the 7th term that actually does this, if you count 7. And we know that's going to be the next one that you add. So really, the number of terms to get to an error of 0.001 is actually 6 terms. So that would be our answer right here. And then the next part to it that I forgot to write down is, would it be an underestimate or an overestimate? And that we determine based on if it's negative or positive on the next number. So after our 6 terms, which is our sixth term is 1 over 720, our next term is negative 1 over 5,040. So since that's a negative, that we know this sum right here of the 6 terms is an overestimate because the next one's negative. So our final answer would be 6 terms to get an error of 0.001, and it would be an overestimate.